This video covers the ALEKS topic of set builder and interval notation. So let's first talk about when we're going to use set builder and interval notation, and that's when solving an inequality. So solving an inequality is the process of finding the set of numbers that make an inequality a true statement, right? We call this set the solution or the solution set, and we say that all numbers satisfy the inequality. Now, we've primarily been graphing our inequalities, but in order to show our solution set, but we can also write them in interval and set builder notation, which is what we're talking about today. So for interval notation, square brackets indicate that endpoints are a solution. So sometimes a solid dot on a number line, this is used with less than or equal to and greater than or equal to. Parentheses are used to represent endpoints that are not solutions, which is sometimes a hollow dot on a number line, so greater than, less than, or greater than. And infinity and negative infinity, those guys always get parentheses. So for example, if I wanted all numbers less than 0, I could graph this on a number line. Here's 0. So I'd put an open circle at 0 and shade to the left. That's its graph version. But I could also write it in interval notation. So we're going from negative infinity all the way to 0. If I wanted to look at all numbers greater than or equal to 4, I'd put a closed dot and shade it to the right, okay? So 4 is in my solution, so it gets a bracket, and in positive infinity, which is over here, always gets a parenthesis. So that is interval notation. Set notation, which you talked about in the video before this one, is also called set builder notation. So set builder notation uses a variable, typically x, to define a set of numbers. So for example, this says that we have a set where x, all elements x, such that, that's what this bar means, such that x is an integer between -3 and 4, right? So what is that describing? Well, it's describing all the integers between -3 and 4. We could also list all the elements. So the integers between -3 and 4, not including -3 and 4, would be -2, -1, 0, 1, 2, 3, right? This would define this set. So here's a summary of interval types, what they look like in set notation compared to what they look like in interval notation. This is a really good reference. Maybe you want to take a screenshot of this or make sure you have this in your notes, because we're going to work through a couple examples. So let's graph these sets on the number line, then write the set using interval notation. So this is the set of elements of x, all elements of x, such that 0 is less than or equal to x, which is less than 6. So 0 is included in our solution. So is every number all the way up to 6, but 6 is not included because it's strictly less than, and we highlight in between them. So in interval notation, we have a closed bracket at 0, comma, all the way to 6, where we have an open bracket. For number 2, I have x such that x is greater than -5. It's strictly greater than, so we have an open circle at -5 and shade to the right because it's greater than. In interval notation, this would be a parenthesis because it's an open circle. From -5 all the way to positive infinity, that's what's over here, and infinity always gets a parenthesis.